Large language models, or LLMs, are increasingly used in educational settings around the world, but most of these models are designed with a strong focus on English. This research paper, titled Multilingual Performance Biases of Large Language Models in Education, investigates whether these models perform well enough in non-English languages to be reliably used in multilingual educational contexts. The authors, including Vansh Gupta, Sankalan Pal Chowdhury, Vileem Zawar, Danya Ruin, and Rinmaya Sachin from institutions like ETH Zurich and Bocconi University, conducted a detailed evaluation to uncover potential biases and performance gaps. The study begins by highlighting the growing role of AI in education. These tools can provide personalized instruction, targeted feedback, and interactive tutoring, which help address challenges in learning. Models like GPT, Gemini, and Llama have shown promise in supporting teachers and students. However, despite being trained on multilingual data, LLMs are still predominantly English-centric, meaning they might not work as effectively in other languages. This could widen inequalities, especially in diverse educational environments where languages like Hindi, Arabic, or Ukrainian are common. To address this, the researchers selected 4 specific educational tasks that involve language and are relevant to real-world teaching scenarios. These tasks are: first, identifying student misconceptions, where the model analyzes a student's response and points out errors in their understanding. Second, providing targeted feedback, which means giving constructive advice on a student's work. Third, interactive tutoring, involving back-and-forth conversations to guide learning. And fourth, grading translations, where the model assesses the accuracy of translated text. They chose these tasks based on 3 key criteria. First, they had to be directly relevant to education, focusing on roles like tutors or teaching assistants, rather than general tasks like math problem-solving. Second, each task needed a significant language component, so it could vary across languages and test the model's multilingual capabilities. Third, the evaluation metrics had to be language invariant, meaning they could be applied consistently across different languages for fair comparisons. The evaluation involved testing 5 popular LLMs: Claude, Gemini, GPT-4o, Llama, and Mistral. These models were assessed on the 4 tasks in 7 languages: English, Hindi, Arabic, Farsi, Telugu, Ukrainian, and Czech. The researchers created a dataset of about 91,000 model outputs, which they made publicly available on GitHub. This allowed them to measure performance automatically and compare how well the models handled each language. Their findings revealed that performance generally correlates with the amount of training data available for each language. For instance, languages with more representation in training datasets, like English, tend to have better results, while lower resource languages such as Telugu or Farsi show poorer performance. Overall, the models performed reasonably well in most languages, but there was a noticeable drop compared to English. Specifically, GPT-4o and Gemini 2.0 Flash emerged as the top performers, suggesting they might be more robust across languages. An interesting observation was that using prompts in the task's native language didn't significantly improve results compared to using English prompts. This indicates that even when models are prompted in a specific language, their underlying biases towards English can persist. In the introduction, the paper emphasizes that education is a multilingual and multicultural endeavor. AI tools have the potential to enhance learning experiences globally, as noted in recent studies. However, without proper adaptation, these tools could introduce harms, such as spreading misinformation, failing to align with local curricula, or producing culturally inappropriate content. The authors stress the high stakes in education, where inaccurate AI outputs could affect students' progress. Moving to the methods section, the researchers ensured that their tasks were carefully designed to be comparable across languages. For example, in identifying misconceptions, they used scenarios where a student's explanation in a given language needed to be analyzed. The evaluation metrics were kept consistent, such as accuracy scores or similarity measures that don't depend on the language itself. The results showed that while some models like GPT-4o maintained strong performance across languages, others varied more widely. For lower resource languages, the performance gaps were significant, underscoring the need for more diverse training data in future LLM developments. The paper also notes that practitioners should not assume a model works well in a non-English language just because it does in English. This research contributes to broader discussions on multilingualism in AI, particularly in high-stakes fields like education. It builds on previous work that has examined LLMs in various domains, highlighting the importance of rigorous, task-specific evaluations. By releasing their dataset and code, the authors enable further studies and improvements in this area. In summary of the paper's key implications, the authors recommend that educators and developers verify an LLM's performance in the target language before deploying it in classrooms. This could involve pilot testing or using the provided dataset for benchmarks. Ultimately, addressing these multilingual biases is crucial for making AI tools more inclusive and effective worldwide.